Subscribe now.
You are welcome once again in today's tutorial. Moving on from 2-point DFT to 4-point DFT. When I say 4-point DFT, it means that the elements in the sequence can be counted as 4 elements. So if we have 0, 1, 2, 3, the elements are 1, 2, 3, 4. So in this case, the length of the sequence is n equal to 4, and therefore we call it 4-point DFT. So now let's go ahead and solve some example. But before that, since it's a forward DFT, we are going to find the general formula is going to be x of k equal to summation of n equal to 0, n minus 1, x of n exponent negative j, 2 pi over n, and then nk, where k to be equal to 0, 1, 2, and n minus 1. So now let's go ahead and use this technique to solve this example over here. So the example says that use direct computation to find DFT of the following, which is x of n is equal to the first one. I'm solving the first one and the last one. Let's say the first one, the second one, and I'll show you some property of which you can use to find the other ones as well. So what you can do now is that when we are doing for x of n, so solution, so x of n is equal to 1, 1, 0, 0. So solving this is a 4-point DFT, and you are going to do the direct computation. So first of all, our x of k is equal to summation of n equal to 0, 4 minus 1 because it's 4 elements, and then x of n, then exponent negative j, 2 pi over 4 nk. This can also be written as x of k equal to n equal to 0, and then 3 x of n exponent negative j pi over 2, and then nk. So now nk. So based on this, what you can do is that we are going to substitute whatever we have for k to be equal to 0. Remember that whatever n, the coefficient of n will be, the whole element will go to 0. So for k equal to 0, we are going to get x of k to be equal to summation of n equal to 0 and 3 x of n exponent 0. So if n is equal to 0, still now we are going to get x of 0 multiply the exponent of 0 plus x of 1 multiply the exponent of 0 plus x of what 2 multiplied by the exponent of 0 plus x of 3 multiplying the exponent of what 0. Because the exponent 0 is equal to 1, we can go ahead we can go ahead and then simplify it. So basically, if you can observe, it means that always the first element is the summation of all the sequence that has been given to you. Looking at the sequence is 1, 1, 0, 0. So f of x of 0 is 1 multiplied by 1 plus 1 multiplied by 1 plus 0 multiplied by 1 plus 0 multiplied by 1. So here we are going to get 1 plus 1 plus 0 plus 0, which is equal to 2. Taking k to be equal to 1, we are going to get x of 1 to be equal to exponent n equal to 0 to 3 x of 1, x of n exponent negative j pi over 2. But since k is equal to 1, it's 1 multiplied by what? N over there. Now we can see that if n equal to 0, we are going to get x of 0 exponent 0, right? Plus if n equal to 1, we are going to get x of 1 exponent negative j pi over 2, right? And then plus if n is equal to 2, we are going to get x of 2 exponent negative j pi, and then when n is equal to 3, we are going to get x of 3 exponent negative j 3 pi over 2. So now that we have 3 pi over 2, what we can do is that we simplify them. We simplify them here, And when we are trying to simplify this, obviously the first part, since here 0x of 0 is what? 1, we are going to get 1 multiplied by 1 because this part is going to give us 1. And then plus x of 1. What is the value of x of 1 per the sequence that we were given? It's 1. And then what is the value of the simplification of exponent negative j pi over 2? That one is minus j. And then plus the other one, the coefficient x2 and x3. If you look at the question that was given to us 0, 0, so whatever the exponential value here will be, we are still going to get 0. So we are going to 0 plus what? 0. And for that matter, we are going to get 1 minus j for the other one. 1 minus j for the other one. So when we have this one, let's proceed and do for k equal to 2. So when k is equal to 2, we have s of k equal to summation of n equal to 0, and then 3 x of n, and then exponent negative j. And then since it's 2, it's going to get 2 pi. Let's say the k equal to 2 pi, and then n over what? 2 already. So 2 cancel 2. So finally we are going to get s of k to be equal to exponent n equal to 0, 3 x of n, exponent negative j pi n. So now let's try and simplify it. For n equal to 0, we are going to get x of k, let's say x of k, and now the k is 2, is equal to x of 0, right? Exponent, because n is 0, we are going to get 0, plus, now when n equal to 1, x of 1, and then when n is 1, we are going to get exponent negative j pi, plus x of 2. And if x is equal to 2, we are going to get x of 2 exponent negative j 2 pi, plus x of 3. Since n is equal to 3, we are going to get it as multiplied by negative j 3 pi. That's how everything goes. So now we have this. What we need to do is that we simplify them. As I said earlier on, obviously the first one is the same value in the sequence, and the x of 0 is 1, right? Plus x of 1. X of 1 is 1, but when we multiply by the simplification of this one, exponent negative j pi, we are going to get negative 1. Negative 1. So since we are going to get negative 1, what we can do is that we do for the second one, which is plus. Because the coefficients are all 0, 0, we are going to get 0 plus 0. In the case whereby you meet a question whereby the coefficient is not 0, you need to also do simplification of this exponential, like the way I did for this exponential, to be able to find the value of that exponential function and then multiply by the coefficient. So in this case, I'm going to get 1 plus negative 1 is going to give us 0. And then the last one that I want us to talk about, don't have much space here, so let's talk about it over here. So for k equal to 3, I'll show you something right now. For k equal to 3, what you can do is that you write the same formula, s of k equal to summation of n equal to 0, 3 x of n, and then exponent negative j, right, negative j pi on 2, and then we multiply by 3n, and k equal to 3. So when k is equal to 3, that's what we are going to get. And when we get that, we can go ahead like s of 3 to be equal to exponent n equal to 0 and 3. So for n to be equal to 0, we are going to get that exponent to be what? That exponent to be, let's say, 0. So for the meantime, I need more space. Right, yeah. So now we are going to get n equal to, for n to be equal to 0, we are going to get x of what? 0, exponent 0, as I told you earlier on. And for n to be equal to 1, we are going to get plus x of 1, exponent, right? Negative j 3 pi on 2, right? And then plus x of 2 when n equal to 2, we are going to get exponent negative j3 pi, because the 2 cancel out 2, and then plus when x is equal to 3, we are going to get exponent negative j9 pi over 2. So now that we have this, we can further simplify it. As I told you earlier on, the first value is always the element inside the sequence. So it's going to be giving us x of 0 is 1 plus, and then x of 1 is also 1, and then the simplification of this exponentiation calculator is also going to give us j. So if we have that, the coefficient x2 and x3 are all 0, 0 in the sequence, so we don't have to waste our time computing them like the others. So now we are going to get 1 plus j. So I can say that my final answer to x of k is equal to the first one. Let's look at what we got for the first one. The first one, we got 2. The second one, we got x1 minus j. The third one, we got 0. So let me write it here. So 2, and then we got the second one is 1 minus j, and then the third one is 0, and then the fourth one is also here, which is 1 plus j. So now that you have seen this here, let me show you something simple here. We have a property of DFT called complex conjugates. So when you are able to find the first one, the second one, and you know the third one, you don't need to find the other one. So as you can see, this part is a complex conjugate of this end, and therefore this will fetch the answer for you quickly. So for now, this is what I've done so far for this tutorial. So before I go to the next question, I'll leave them for you to try. This is the next question. Yeah, I've done this. The same procedure, I want you to proceed and do this. Do the 1-1-1 approach. Pause the video and do the 1-1-1 approach. So x of n is equal to 1, 1, 1, 1. And since x of n is equal to 1, 1, 1, you're supposed to get something like x of the same process, x of 0 to be equal to 1 plus 1 plus 1 plus 1. As I told you, they are always the combination or the addition of the element in the sequence. So we are going to get 4. So for the x of 1 is equal to, always the first element is the element inside it, because the exponential one is going to be 0, and then plus the second element is going to be j, right, j, and then the third element is going to be negative 1, and then the fourth element is going to be negative j, and we're going to get 0 here. The same thing applies to x of 2. And x of 2, the first element is also going to be 1, minus the second element is going to be negative 1, and then plus the third element is going to be 1, and then the next is negative 1. Then we are going to get 0. And then the last one, it's x of 3. And for that matter, the first part always 1 minus the j minus 1, and then plus what j, and that one also give us 0. So based on that, we can say that our x of k is equal to 4, 0, 0, 0. So this is how the 4-point DFT can be solved. So you can decide to solve the first 3 and find a complex conjugate for the last one, or whatever you want to do. So this is very important over here. You need to understand this. So to make sure you understand this example and this tutorial, I have this trial question for you. I've done this. So please do these two. There's 1 minus 1, 1 minus 1, and you are supposed to get the first one, the answer to be 0, 0, 0, 0, and then the next one, which is the 1, 0, negative 1. For that matter, that one too, the answer 1, negative j, and then -1 and then G. So as I told you earlier on, you can see that after the first element, the second one is a conjugate of the other one. So that's how things has been done over here. So please try your hand on this question, and if you have any issue or you encounter any issue, please send it via the comment section so that I can help you out. So thank you for watching, and see you in my next tutorial.